Good morning. Okay, today is Tuesday, the 14th of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, and I stream Monday through Friday here on Twitch. I am working on a project called Basecode, which is a new programming language that I'm designing, and building the Bootstrap compiler, which is written in C++. Off stream yesterday, I made some pretty good progress. I actually, what did I do? I actually introduced the AST evaluator. So in the element model, the code DOM for the compiler, the program used to have quite a bit of behavior on it. It still has some behavior on it, but it's much, much smaller now. I've moved pretty much the entire AST evaluation to the AST evaluator. So now program is 882 lines of code. And again, some of this stuff probably can be further refactored to other things. Then the AST evaluator took on evaluate and scope, and then a bunch of the support functions to allow that to work. And then I translated that switch statement into a map with functors. So if we look at the CPP file, now there's a static unordered map with the AST node type, and then a node evaluator callable. A node evaluator callable returns bool. This is this parameter. And then it accepts an evaluator context t reference and an evaluator result t reference. I did that because based on past experience, I knew that having to change the prototype of these was going to be painful. So I decided, okay, I just want to pass either a pointer or a reference to a struct and return a pointer or a reference to a struct. And I just decided to pass both things in and return Boolean. So then evaluate, instead of having that huge switch statement, we still check to see if node is null, and if it is, we return. We create an evaluator context, which gets the result in the session. We set the node that came in. We set the scope, and we set the default block type. And then we look up the evaluator by AST node type. If we found it, then we create a result. We call it, right? And so we're kind of emulating OO here. This is sort of an emulated double dispatch. So I have to pass this pointer manually because the compiler is not building this for me. I'm doing it on the fly. We pass the context, we pass the result. If it was successful, it returns true. Result has currently just one element pointer on it, but eventually that's going to change. If it didn't succeed, we generate an error. If we couldn't find an evaluator, we return null, just like we did previously. This eventually probably should generate an error. However, like I've taken all the AST nodes, I have a no-op evaluator that just does nothing. So right now it always finds something, but eventually, like if I keep adding things to the AST or changing things in the AST, there will be a case where we don't find it, and that should be generating an error. Apply attributes, evaluate in scope. This, I think, is going to be a lot easier to refactor now. But yeah, I'm going to come back to this. A lot of these need to be cleaned up, right? Now that I've kind of refactored these, moved them, I can actually simplify a lot of their prototypes. I did simplify resolve symbol or evaluate. It takes in a reference, const reference to the context and a pointer to the node that it should be evaluating or converting. But down here, these are the evaluator functions. So these used to be the cases in that switch statement, and now they're standalone functions that are called through evaluate. And they set the element on result. That's how the evaluator gets whatever it is they create. And I just went through and took the case implementations and moved them into these functions. A couple of them changed this ever so slightly because the API is a little bit different. But for the most part, they're exactly the way they were. This file ended up at 1,240 lines, of which quite a few, 57 lines are just setting up the map. But now to add new support for a new AST translation to the DOM, I just create a method, add it to the map, and implement it. No more switch statement. Performance-wise, honestly, it seemed about the same. I don't think it really changed things too much. It might be just slightly more cache unhappy than the switch statement was. But yeah, I mean, it's about the same. So, and functionally, we're exactly where we were. So that's all good. So that was a huge change. And I want to say, hey, Dr. Robot. I want to say there was something else I did yesterday. It was kind of worthwhile. Oh, yeah, comment indentation. So I got tired of, like when we're inside of a label like this, I got tired of these comments hanging off on the left. So I implemented some simple capability to control what indent level comments are at. And this was really what I was looking for. I was looking to just have this line up with that little block of assembly and then be able to put a line break in there so that it's a little easier to read. So today, one of the things I would like to fix first is disassemble. No, disassemble number 5. Sorry. I've known for a while, right, that this is not formatting things properly. And with the changes to, we now have this alias thing, right? So I can do a register alias, value alias T, yep, short circuit. And as we loop through the operands, and so we get the operand down here. So if it's a register and it's integer, we're going to format the register name. Otherwise, if it's unresolved, we're going to show IDs and stuff. And then here, instead of that, right, we're going to use our alias structure, and we're going to switch oh no, it would be on, yeah, it's just size. And then I'm wondering, can I just like, but I don't know what, this is ahead of the operand stuff. Okay. Excuse me. And that should take care of the incorrect formatting for some of the values. The instruction size specifier was correct, but the formatter was formatting them as quad word or whatever. So yeah, here we go. So we're only seeing a byte, we're only seeing a word, word. Yeah, perfect. That's correct. Good. Yeah, that fixes that problem. A little extra code, but not horrible. So what we did there, so I got rid of the comment that was reminding me that it wasn't right. And then as we loop through the operands, I create a register value alias t, which this is a union, and I assign the 64-bit value from the operand, because the operand has fewer aliases in it. It has U, an R, an F, and a D, I think. Because for storing the operands, that's all that we really need. But the alias has all of the sizes that the instructions can support. And then down here, offsets we're always just going to format out the way that we have been. They're kind of a special case. But the main operands, we emit the prefix, we look at the size of the instruction, and then we output the correct formatted value. Instead of just always formatting the 64-bit value, which would result in seeing parts of the register that we really didn't want to see. And then the postfix if there is one. So pretty simple. And of course it doesn't fit. Okay, that's done. So I've made progress on these two. I think there's, like I say, there's a lot more there that could be improved. So certainly one thing is we could change this to be const evaluator context. And we could do the same thing here, same thing here, here, and actually, no, yeah, we gotta do that there. Okay, we already did it on that one. Because the evaluator context has the session on it, it has the result on it. Sorta. I need to do some more refactoring to get to that point. But yes, that is the ultimate destination. Yeah. Some of this stuff still lives on program. I haven't refactored it out yet. And I don't want to get in a case where like program is having to depend on AST evaluator and wait. Yeah. At some point, I'll be able to refactor some of this stuff so it's all on one side essentially, and then yeah, then it should be a piece of cake. Now, I do think, though, yeah, evaluate and scope, we could, because it's only called, what we should do, this guy can participate. Yeah, so that leaves evaluate as our one. Well, it's recursive. So I do kind of have some thoughts about potentially making it not be recursive in some spots. But yeah, I couldn't really make it a global. Obviously, if I put a stack in it, right? If I emulated my own stack, then yes. Make sure that didn't break anything. I don't expect that it did. Good. Okay. So let's take a look at program. So we have this error stuff, right? So what am I trying to say? I don't know. So one thing we could do is, as it relates to compilation, is there a good reason why session and result are independent of one another? And I'm having a real hard time coming to a good rationale for that, other than it's just the way that it was. Yeah, because I'm creating both here. A compilation session is going to have results. Yeah, and then if we move result for the compilation session onto session, then we don't have to pass anything to compile. Compile can just be, actually you don't have to pass anything to either of these because the result will just be internal. So need to pass that. We don't need to pass that. Oops. Hey, Miss Sugar Sahim. I'm doing okay. Yeah, that one we'll just fix. It's already get session. Yeah, so here's where already can delete. Of course, that's going to ripple everywhere. That's okay. We'll fix it. Excuse me. Hey, Kubisus. Hey, 123 film. I'm doing good. That's right. Hey, Quesadilla Quantum. Hey, Silence Edits. I'm doing well. How about you? It's always a good day when I'm able to delete code. Good thing I don't have many of these. I gave Code Academy for Python a try. My brain is still stuck to syntax, but I don't know how to reframe from that. I'm still doing Code Academy. I'm 27% in. Should I keep doing it until my brain reframed from learning the syntax as well? Okay, so hold on one sec. It's bad if I stop in the middle of a refactoring. I'll lose my place. That simplified that. I'm just several more passes of folding and consolidating. I don't like that one, but I think that stuff's all going to move anyway. Okay, so Silence Edit is asking about coding, and if I remember our previous discussion on chat, it was centered around, I think what I said was syntax isn't important, right? So, and perhaps you took that too literally. So let me clarify what I mean. You have to learn the syntax for a language. That's not what I meant. So the fact that you're learning syntax by going through a training program is fine. What I mean is there is a propensity in software development for us to look at all these languages that are available and we think there's something special there. We think that because they use square brackets instead of curly brackets, or because they, whatever feature it is that attracts programmers to it, it's this endless fascination with, oh, that looks different than what I'm doing, therefore it's special and magical, and if I learn that, I should do that, right? It's like, in a way, it's the exact same belief system, I think, that works around the editor wars, works around tabs versus spaces, works around all these things, right? Because it just might be that if I'm doing one thing and somebody else is doing something else, then they know something I don't know and it's magical and I better learn it, right? That's the thing that I was trying to convey. You still need to learn the programming language. So there's nothing wrong with the first 2 weeks to a month of any new language being the time you spend becoming familiar with it. However, exactly, Basecode doesn't have quantum mechanics, bracket operators, right? So, it's fine that you're using a training course, it's introducing you to Python, you're learning the syntax. However, the other side of this, and perhaps I said this explicitly and perhaps I didn't, I don't really remember, but again, just because you go 100% through this Code Academy course and you learn all of the syntax and grammar to Python doesn't mean that you know Python, right? The important thing, no matter what, is you must build something with it. It has to be a tool that you use, that you actually put into the grinder and have something come out the other end that isn't just a bunch of memorization and whatever test they give you. I don't even know, right? I've never even used Code Academy, but you have to use it. And guaranteed, you're going to feel like you didn't learn anything. If I were to put myself in that position and I hadn't known anything about a particular language at all, I'm sure that going through something like Code Academy, I'd come out with this superficial understanding, but then once I actually used it, I'd think, wow, like I didn't learn anything from that training program. Now again, don't misunderstand me, I'm not dissing what you're taking at Code Academy, and I'm not telling you to stop. I'm telling you that it's the beginning, right? It's only a very small portion of what you have to do, and that the large portion of what you have to do is to write code. You have to actually write code. So as long as you keep that in mind, and don't fall into the programmer trap that there's magic in them there are heals. If you just follow the lucky rainbow and get your magic charms, it doesn't work that way, right? It really doesn't. And this is why I always tell people to start with assembly language. There's a real, solid rational reason for that. Because we all write code on top of machines. We like to pretend that they're not machines, but they're machines. Now, CPUs are amazing marvels of human ingenuity, right? They are the closest thing that we have gotten to mimicking the awe-inspiring complexity and miniature scale of biology, right? It's not biological, but it's our analog to it, and it's really, really frickin' impressive. But it's still a machine. And that machine has limits. That machine has a certain fundamental configuration to it because it's a physical thing. And it can only operate within the parameters of those physical realities. Okay? All this other shit that programmers put on top of that machine, right, are just ideas that programmers put on top of it. And some of those are decent and quite a few of them are not, right? But fundamentally, what you're going to learn is once you've used as many programming languages that I have, they all are the same. They all work the same way. They all do the same things. Yes, one might have syntax that's more advantageous for X over Y, right? But that's irrelevant. Why do they work the same way? Why do they do the same things? Because fundamentally the machine is the same. The thing that they are targeting, the thing that is running the code, doesn't change. The only languages I would say that are unique, but then there are lots of limitations around this. Rich Hickey's transactional memory stuff, enclosure, and there's other variations of this, right? It's not just his. But there are some functional languages, right, that they burn CPU cycles to emulate a sort of behavior that does not exist on the hardware. And that's great, right? That I'm not saying it's bad. I'm not saying that we shouldn't ultimately maybe have things that do that at the hardware level. We probably should, but we're not there yet. The machines don't really do those things. We have to emulate them, and that's expensive. So that's why there are limitations around those concepts and why they tend to be kind of sequestered, I would say, in languages that are not, let's face it, they're not popular everyday workaday languages, right? They're more research and exploratory languages that people are using to try to understand like where the machine could go. Now, interestingly enough, there are special cases, and I'm not trying to confuse the issue, but again, you have to think of hardware and software together. Like if you take IBM, for a number of years, they don't do this so much anymore, which I think is a mistake, but they used to have proprietary CPUs that had special instructions that would do things that normal CPUs would not do, which allowed them to support backward compatibility for decades in some cases, and they could do it without a loss of performance. But typical CPUs don't have that kind of functionality. So anyway, long story short, you're doing the right thing, learn the syntax, but use it. You have to use it. And yes, the first time you open a blank file and you try to build something, it's gonna suck. Just be prepared for that. That's okay. You're no different than anybody else, right? Nobody's code is perfect. Nobody does it right the first time. You're just going to learn. But you have to do that next step. That's the key. Hey, Soding. Python is really God for people who don't want to be programmers, but still want to make... Python's fine, right? Like, I get it. There are a lot of people who write code, and that code does not have to be the most performant code on the planet. There's lots of scenarios where you're doing operation stuff, you're doing glue, you're doing whatever, and it just doesn't really matter. I think that's the other fallacy that we programmers have, especially for server or distributed type systems, because it's cool, I get it, and because everybody wants to have experience doing the really fancy hard thing. But the reality is, with the exception of probably 20 companies, you're never ever going to need to shard. You're never ever really going to need to distribute. You're never ever going to have... There is hardware that exists today that is commodity that will not break your bank, that can run everything that your organization does on one machine. Now that's really unsexy, that's really unpopular, it's really not, something that everybody wants to admit, because if they did, then it would be too simple, right? But that's the truth. So, now, if you're making things on a local machine and or you're doing embedded, you have size constraints, you have performance constraints, fine. That makes sense. But there's a lot of folks that don't have those problems. Dr. Robot says, you mentioned assembly simulators a few weeks back, but would you recommend a learning resource to begin building in assembly? Honestly, if you Google assembly, you're going to find lots and lots of stuff. There's university level stuff, obviously, that you could take, that I think most of that stuff is good. There's lots of tutorials over the years. Now, a lot of stuff is probably going to be for CPUs that are not, they're dead or they're lesser used. But again, it doesn't really matter. I don't think that it matters that you learn the assembly language of a commonly used or currently used CPU. That's not the point. Again, that's missing the forest for the trees. You can learn 6502, you could learn Z80, you could learn 68,000, you could learn 6809, you could learn a variety of TI dialects of assembly language, from their calculators all the way up to computers and GPUs. You could learn, x86. The idea is that you learn one of them, you find a resource that fits that one that works for you. And Peter Norton used to write books back in the 80s, and he had great assembly language tutorials. I used a lot of his books. Again, it's all outdated stuff nowadays, but it doesn't really matter, right? You get DOSBox, you get your Peter Norton book, and you go through it, and you're going to learn a lot. And if I remember correctly, at least 2 of his books, he used the debug program in MS-DOS for a lot of it, right? So he didn't even need an assembler. Eventually he introduces an assembler, but he doesn't start that way. So yeah, there's tons and tons of good references. I would steer clear of maybe like Michael Abrash's stuff. He's more into like optimization. Once you're familiar with a particular type of CPU, then that information is valuable, but you don't want to start there. That's going to be confusing. Lori Master says, I'm in the field of physics, and for both physicists and mathematicians, Python is really widely used. That is because programming is not taught to them in academia, but you truly need it. So Python is a nice middle ground. Yeah, again, if you're if you're building something where you just, again, it's a tool, right? For a lot of people on the planet, writing software is just a tool. It's not a means to an end in itself. They're just users, and that's fine. There's absolutely nothing wrong with that. I mean, again, I will tell you that, one of the most common programming languages outside of COBOL would be Visual Basic, scripting. So VB Script or some variant of it. Why? Because Microsoft put it in all their tools. And because the people who use those tools every day discovered that they could write their own software. Is it well architected, well designed, following computer science principles? No. Doesn't matter. It's just like if they had to go do some woodworking, they produce some horrid, glued, screwed, probably not square solution, but it probably would get the job done. And that's okay. Like I say, everything is context. Hey, Sir Rackley. How's it going? And that reminds me of another topic. I had a conversation with some folks that I know that were in the cryptocurrency space. Notice the past tense. And I would like to make the observation because I think it's interesting and timely. It's August. When I started streaming, practically every day, somebody came in and asked me what I thought about cryptocurrency. Have you noticed that no one's asking anymore? Oh, okay, gotta change the battery. One sec. Yeah, I can't wait till I get my AC power supply for this. I'm a robot. If I don't put this on a different screen, it glitches. There you go. Camera fixed. What was I saying? Oh yeah, have you noticed that nobody asks about cryptocurrency anymore? That fad's done. Yep. I would say the fad has ended. What the heck? Oh. It'd be kind of cool if I were a robot. It would mean I'm not really getting older. Alas, I don't think that's the case. Let's see. Alens, how important is following best practice of doing my very first projects? At the moment, a basic console dungeon game. I am ashamed to write code because it might be horrible even if no one sees it. Again, so here's the thing. You're learning, so you get a pass. You know, it doesn't really matter if you do it perfectly. Nobody does it perfectly. Look at me. I mean, I'm refactoring my code. And generally speaking, the steps that Flathead Screwdriver mentions are accurate. You want to make it work, then make it correct. You know, make it like what I'm doing. I'm slowly improving the structure of how I build things so it's easier to work with. And then you can make it fast. However, the premature optimization is the root of all evil. That quote, unfortunately, I think context and history have kind of ruined that quote. Yes. Well, so I have several things to say about that. One is that I think primarily you want to avoid concerning yourself too much, at least initially. Once you're skilled, once you have more experience, this becomes easier. But even still, micro optimizations are secondary, okay? What does that mean? What that means is that in a vacuum, we could argue about whether XORing a register with itself or moving a value to it at the CPU level is better, it's faster. I know that's a horrible example, but it's a simple one, okay? We could argue, you know, you will hear people still to this day tell people that they should write their loops backwards because writing your loop backward will actually cause, you know, the compiler to generate slightly more optimal loops and one fewer condition checks, and you'll hear this shit, right? So I think generally speaking, don't worry about that stuff. Right? That stuff is not, there's a time and a place for that sort of stuff, and that really typically can be deferred, right? Micro optimizations, as in here's this function, and if I restructure it this way, that will cause the compiler to generate this kind of assembly code, which is 2% faster, right? Or yield some other positive benefit. It doesn't stall the pipeline, the prediction pipeline, or something else, right? But those are things truly that can be deferred. Now, where that statement can get you into trouble, though, is you do want to start practicing understanding how to design things. And that's part of programming. And The story I always like to tell here is the story of Quake. And it's really hard for people nowadays to understand like how truly impossible it felt and how amazing it was that it managed to get Quake to work the way that they did, not inverse square root, no. How they managed to get that 3D rendering to work as well as they did on the commodity hardware of the day, which you have to remember was a 486DX, which was probably running at a top speed of 66 megahertz. And it had, if you were lucky, you know, on average 4 megabytes of RAM, probably less in practice on a lot of machines. So there's books out there, you can get them, they tell these stories. But my shorthand recollection of the story goes like this. You know, id hired Michael Abrash to help John Carmack because they were having, admittedly, a hell of a time getting the 3D renderer to actually perform anywhere near reasonably in Quake. They could get stable frame rates based on the structure of a level, right? So if the level was enclosed and it was mostly hallways and all these other things, they could get reasonable performance. But as soon as they moved into open areas, the program would tank, frame rate would drop, it was horrible, right? It was not consistent, and they tried all sorts of things, okay? And for a very long time, you know, and I believe the version of this that I read was written by Michael Abrash. And they would try all these micro optimizations. They would try unrolling loops and making specialized texture mappers and all this stuff. And finally, they reached this point where they realized there was no way to brute force this. There was no way to micro optimize this. This had to be, either there had to be a design that allowed it to work, or they were screwed, right? They weren't going to get it to work. And so then they went down the road realizing that it was all about their data structures and optimizing their data structures for the problem that they were running into. And specifically the problem that you ran into on hardware of this time, which sounds really, really silly today because, you know, 320 by 240 is nothing, but the issue was that they were overdrawing the screen too much. And CPUs of that time, you could fill the screen once per frame. That was it. That was about the overhead you had, you know, the latitude that you had. But if you overdrew parts of the screen more than once, your performance plummeted. So they came up with an algorithm that solved the problem. And that's what made Quake possible. Not them going in and yes, were there micro optimizations? Sure. But the big part, the part that really mattered, was the design. And that's, it's a good story to read. I forget exactly which book it was that I read. I know it was Michael Abrash who wrote that because it was from his perspective. It's worth a read. If I find the title, I'll post it up here. But the idea generally holds, right? You need to design the design of your application is far more important than whether or not you put that particular thing on the stack or that particular thing on the heap, or, Those are things that you can probably shuffle around as you need to. Now, if you've built certain kinds of programs, like I'm going to use like Casey or John as an example here, they have built certain kinds of games enough times that they know the end game. Right? They know what they're going to run into. They know they're going to have 100,000 entities in their world, and they have to loop over this list, you know, gajillions of times during a frame. And so they can seemingly make all these a priori, I can't code this way because it will be too slow statements, because they're essentially following the same design pattern over and over again. Now, I'm not diminishing what they're building. That's not the point of what I'm saying. What I'm saying is that from an outsider or beginner's perspective, it's going to seem like they're making decisions that are micro-optimizations, and it's going to violate what I just said, but they're not. What they're doing is they're using previous experience building very much the same thing, and that's what's guiding their approach to things. The other thing you have to keep in mind about game development, if you're watching guys that are building actual games, and they're in the AAA space, you have to understand that they're not probably optimizing for the PC in the main, right? Like, yes, they want the PC to perform well, and I'm not saying that they don't make decisions that are good for the PC. They do, but what often you run into with game development is that you're targeting consoles. And even though consoles are much closer to PCs today than they ever have been, they're still cost-reduced machines. So typically they have bus limitations, and they have the kinds of memory that they use are constrained in some way, or the machine might have multiple CPUs, but you can only use certain CPUs for certain parts of the memory map. You can't use them for everything. And the list continues, right? Accessing secondary storage is conceptually the same as what you would do on a PC, but it's very, very slow, or it can't go into video memory directly. You have to copy it, right? There's a whole bunch of reasons why consoles are much slower. Oftentimes, like, the PC and a console might be an Intel of some kind now, but or maybe an ARM or something, but let's just say it's an Intel chip of some kind. But again, it's cost reduced. So the L1 and L2 cache is probably smaller. So you're going to be hitting main memory a lot more, which on a machine that's already cost reduced is probably a problem. So you have to keep that in mind. And this goes back to understand the hardware. You know, you have to know where your thing's running in order to really understand, you know, globally what your limitations are going to be. It could have been the Xenographics programming. I'm horrible with names and memory. I would really have to troll around and find the book. my recollection, what I read, it was specifically about, it was Abrash's recollection of his time at ID. That was and he just happened to talk about all the stuff that they did to try to get Quake to a point where it was usable. And the following statement is in no way me making fun of Jessica at all, but if you're worried about what your code looks like, just go watch Jessica Mack's stream for an hour or two. Her code is atrocious. And she knows it, right? Don't worry about what your code looks like. It's not... Are there dicks on the internet that are going to tell you it looks like shit? Sure. There's probably people that would tell me my code looks like shit. Oh yeah. Yeah, I mean, again, my point here is I would consider Jessica to be a very talented programmer, but her code looks horrible. Yes, see, thank you. Somebody told me my code looked like shit. I'm getting somewhere. You know, my point is, don't get hung up on that, right? You might think your code looks horrible or it's not good enough or whatever until you look at somebody else's. So, yeah, we have to change all those. Am I mean? I don't mean to be mean. If I remember that one, and I don't trust my memory that much, that one though, he was kind of snarky about it, if I remember, but I could be misremembering as something else. No, I haven't really 100% landed on casting what I'm going to be doing, and I ended up doing these cleanup refactorings. This is why I've been trying to stay away from big refactorings on stream, because this is what they end up being. There's just tons of changing and shuffling and renaming and fixing up, and it's not very interesting. Yeah, my recollection was that he was not asking out of any genuine or serious, from any, serious position. It was just more like, yeah, there you go. I think it was more along the lines of, oh my God, your code is so ugly, that switch statement's so big. And my attitude at the time was so. One of the things about switch statements that you have to remember is that there's a lot of OO stuff out there. There's a lot of books and talks and other shit that basically says to OO neophytes, if you see code that has lots of switch statements in it, then that means they don't understand OO. They don't understand polymorphism. That's a smell. That's a code smell, right? Hey, Cyanox. Yeah, you know, again, in OO, everything is a hammer, or everything's a nail, and, you know, your hammer is polymorphism, right? And if you're not using that all the time, then you're obviously doing something wrong. Never ask an assembly language programmer what they think of GoTo. It's fine. Most compilers generate switch statements as jump tables. So if you view a jump table as a go-to, then I guess technically, yeah. Again, you know, the go-to considered harmful thing, you have to remember in time that was, you know, programmers were used to writing assembly code, and they were just used to go-to. They were used to jumping around arbitrarily. And then structured programming came out, and people weren't really adopting structured concepts, right? In other words, instead of go-to becoming something you used very sparingly and only when absolutely necessary, people are still using it more or less all the time to structure their programs. And the idea was, hey, you know, everybody, you don't need to do this anymore. But like all, you know, cute little quips like that, it becomes like we lose the context around the time when it was said and what it was really meant to be communicating to that group of people at that time. And so then in modern times, if somebody uses one go-to somewhere because it's expedient or it makes sense, they're Satan, right? It doesn't work that way. But, you know, there you go. Ooh, that was a good refactoring. That went everywhere. All right. Ooh. That touched everything. Where's a good place to start? Well, I guess we'll start in the AST evaluator. So I was passing a reference to the result and the session into the evaluator context. Now it's just the session because we moved the result onto the session. And then a bunch of the helper functions on the AST evaluator now can just take the context because it has the session, which has the result for that session on it. We don't need to pass both parameters. Hey, Slayer Darth. Yeah, so we just pass the session in to the context when we create it. Program error, we just pass session through. Yeah, lots of changes to just taking the context and using what's on the context instead of passing extra parameters. Most of these are just going to be changes to prototypes because, again, now we're passing an aggregate that has a bunch of state on it compared to... Oh, no, this is a DSLR, so you're actually seeing colors the way that they really look. That's pretty much what my carpet looks like. Yeah. Now I didn't go everywhere. I think in AST Evaluator, I think I've refactored everything in here. Yeah. So then if we look at session, I moved result into session because everywhere session was going, there was a result, and really the result belongs to the session. It is part of the session. Compile and initialize used to take in a result reference, which we don't need anymore because we have it. I made raise phase private because now that's being handled inside of parse or compile module, one or the other. I added an accessor for the result. Again, I was passing result into things because it wasn't really bundled with the result or with the session, but now it is, so we don't need to pass that in everywhere. So things simplified a lot here, and we're using the internal result in parse. Yeah, so it was in parse, right? So I call raise phase here for start. I defer the failed or success phase here, and that all just happens internally. So much cleaner. On the program side, error, this variation of error, I was able to get rid of the result because we're already passing the session through. I need to consolidate, really what I need to do is consolidate these two, but I need to do some other changes to make that possible. Compile doesn't need results separately anymore. Compile module doesn't need results separately. And then a bunch of these change to just take session instead of the result. And yeah, and then everything else is just changes because of those APIs shifting. Mostly it's just resulting in us, passing fewer parameters around. And then the rest of this, so the initialize on types was taking a result in the program, but session has all that. So now I just pass a reference to session for those. And then I had to go everywhere and update that. The fold interface is the same. It was taking a result in a program. Now it just takes a session. We already looked at that. We looked at that. These are just changes to some of these interfaces. In main, I made this a const reference, made this const, and we're not creating a result anymore. We're not passing that through because we don't need to. It's on the session. Element builder, some of these are still taking just result, I think, or maybe not. Maybe I did get all of them. No, there's a couple. Yeah, so I still need to go through and update those few remaining that didn't get included in that process. But then when that's done, everything will be taking a compiler session instead of just a result. These were changes to fold and onfold. Directive was able to simplify this because we were already passing session through, which now has the result. So I was able to get rid of the extra parameter everywhere. I am creating my own programming language, yes. Most of these are just changes. We already talked about the evaluator. All right. Very good. Yeah, I wanted to work on cast today, but I started doing that refactoring, and before I knew it, 2.5 hours. Good refactoring, just, they take time. So, and everything still looks good. So I did want to, let's take a look at program. So we've got air, right? And if we look at what air is doing, air is actually very much tied to the session, right? We're ultimately getting to a source file which lives off of the session. So I think these air methods need to migrate to session. The other thing that needs to happen, and this is what I meant when I said I had to make other changes to get these refactored, I think every element just needs to have a non-ownership pointer to the module it belongs to, which we can do because we have as we're building the DOM, we know what the current module is. So on element, I just need to put, either I need to add it to the constructor, so just we always pass in the module pointer, which is probably what I'll do. And then I'll just have an accessor here that returns a pointer to the module. Because what that will allow us to do is get away from having two of these. And the reason we have two of these is because sometimes we know the source file, sometimes we don't. We only know the module, and the module knows the source file it belongs to. Well, if every element has a pointer to the module it belongs to, then we can just go that route with it. So these can consolidate down and they can go onto session. And these will just go away from program. So that's one less thing we have to call on program. Then we have, obviously we have the compilation front end. And then we have stuff for blocks. Pretty much everything else on here is stuff that compiles calling. Type checking, resolving unknown types, setting up types. And then everything still in here is, finding types, creating blocks, scopes, walking scopes or elements, finding identifiers. So, yeah, I'm kind of thinking there needs to be, like, a lot of this stuff very well could live somewhere else. And then program would just kind of get demoted down to being an element again. There wouldn't be much special on him. The other thing that I can do, not the builder, the evaluator, I'm passing both the builder and the program pointer in here, but now that everything has session in here, we don't need program anymore because session has the program pointer already. So we don't need to pass that as an extra. Hi, cache override. So that's another consolidation step that I can take. So I think probably what I'll do the way the casting's going to look, really briefly, this is the way I always thought casting would look. Let's say I have foo and it's a U8 and I want to assign true to it. Well, can't do that, but you can do this, right? So that's what I was thinking cast would look like. That's what the syntax is. Hey, Everex. But the cast operator in alpha is going to be fairly limited, meaning that there are some things you just can't do, right? You can't have you know, this, and you can't do this, right? Like that doesn't work. You can't, that wouldn't work. That's an error. Like pointer types in general are, with cast, I'm not thinking that there's a lot of transmutation, or not a lot of change that can happen there. Cast is really going to be, again, you have a bar, which is a U16, and it's equal to, you know, 555. And you want to assign that to a U8, right? That's what the cast operator would be for. Now, I'm also thinking that there would be a transmute, which I haven't set as a keyword yet. And transmute would be a literal bitwise cast. So there's no truncation happening. There's no, this is really literally like an aliasing type thing. So in other words, I mean, in this case, it's not really, doesn't mean much. But if I had like an F32, right? And I transmuted that, right, it's a mem copy, exactly. Yeah, so like if I have an F32 here and I say transmute this to an, you know, U8, it's gonna take the bottom 8 bits of whatever this is, and it's gonna assign it to, it's not gonna try to translate it, it's not gonna, you know, it's not gonna do anything magic to it. It's just gonna take those 8 bits and stuff them in that, that byte. But that's different from cast, right? Cast could potentially truncate, it could potentially convert in some cases. But yeah, I think Laurie Masters got it right. It's essentially, it's a mem copy. Yeah. This is essentially saying copy the least significant byte of this to this. If this were U16, it'd be copy the 2 least significant bytes to this. So, I mean, as far as casting and conversion is concerned, that's kind of what I'm thinking I'm going to end up with. And I think, you know, casting would be, so if you're casting from an S8 to a U8, it's a no op. If you're casting from a U8 to an S8, it's a no op. If you're casting from a U8 to a U8, it's a no op. Say S8 to S16, widen, U8, S16, widen, sign, extend, actually, extend, just widen, truncate. Yes, technically this is sign extend truncate. And I think the pattern pretty much repeats for the other types. So I mean, this is essentially what casting would do. The only thing, so like F32 to, yes. And the S8 negative 100, well, yes. Yeah, that you would just drop the sign. But if you had an S8, no, I guess that's always the case, yeah. So if you had like negative 127, it would just become whatever that is when reversed. FF, or not FF, it's 8.1 or whatever that is in decimal. So if you had a float and you cast to any int, you get a truncation. Same thing with F64. And F32 to F64 is just a widen. F64 to F32 is a truncate. So that's, you know, give or take, I think that's roughly what cast is going to do for us. Bool to bool is a no-op. Bool any int 1 or 0, any int, or yeah, any int 1, 0, bool. Yes, my intention would always be to go to the closest size integer that will hold the value. So if you had, you know, like, so let's say you had an F32 and it was -3, then it would pick an S8, right? Let's say you had an F32 and it was, you know, 65535. It would pick a U16. So now we could make it like, because coming from floats are signed, so maybe we could say floats are always, when you cast them, they always cast to a signed type on the integer side. I could see that. And then if you wanted to make it unsigned, you could have another cast. I think it would probably pick the most appropriate. Although, off the top of my head, I'm trying to think. Yeah, I'm trying to think how we would do that. Because obviously, if you have a float and it's less than the largest signed integer type, then that signed integer type becomes 0. But I'm trying to think of how we would decide without some kind of, I keep thinking I would need some kind of bound check at runtime. Yeah, so I don't know, that one's a good question. I mean, if it's a constant value, if it's a literal value, then we could probably figure it out. And then transmute. Transmute is pretty easy. I probably could get that one working first. Yeah, so for the floats to integers, I probably would need to generate actual code. But I think most everything else can all just be done at compile time. So anyway, I think that's the game plan for those. So let me do this. I wish, if somebody knows, if there's a template or a way that like you can preset all this shit, because it's really annoying having to pick it every. This is the stuff I don't like about tools like this. I like being able to just like make notes about things, but like it's only me, so I just want to. Okay, So I've got issues for those. All right. I think that's going to do it for me today. Right on time here. Let's see. Lori Master says, I've had the float int problem a couple times, and I remember being bummed that my CPU didn't have intrinsics for correct floor ceiling. Yeah, again, I'll have to look into that. I mean, obviously I could generate code that would do the right thing, but maybe you don't want to pay the price for that, so then maybe I would have to put an attribute or something on there, so we don't do that. I don't know, I'd have to think about that. Can't you make notes through the command line? I have no idea. That's the problem with tools, right? There's just, then you have to learn all the little things about all the, the tools, and it's like, that just takes time. And I'm a whiner, so, you know me. Whine. Anyway, no, the refactoring was good. Lots of cleanup, more to do. I'm going to get the module pointer on element so everything has that pointer on it, and I think that's going to make a really big difference. It's going to simplify a bunch of stuff that's now currently having to be more complex than it should because it's not there. And we'll get things really tidied up, and I'll get some stuff going for cast and transmute. Actually, transmute should be a piece of cake, so I probably will just do that first, and then cast can follow. And what do we have here? Programming. Any suggestions for? Yep, I'll be online tomorrow, 5 a.m., usual time. Creating a starting soon overlay with Rust. Oh, that might be cool. I know how much people love Rust. I think Everex is, he needs more Rust in his life here. Okay, we're gonna raid Brookzerker. He's writing Rust code. So I will be online tomorrow at 5 a.m., usual time. We'll pick up wherever I leave off. I think I'm making pretty good progress. I'm pretty happy. See you guys tomorrow. Bye.